Hello everyone, this is QQQ AI News. AI tools are constantly evolving, and today I will introduce you to the latest developments. What is HiStream 1.0? At its core, it's a powerful AI model that generates realistic, high-quality 3D human animations from simple text descriptions. Imagine typing a person walks forward while gesturing and looking left and right, and getting a fluid, lifelike 3D skeleton animation in seconds. That's the power Tencent is putting into the hands of developers and creators. This isn't just another incremental update. HiStream 1.0 is the first text-to-motion model built on a diffusion transformer (DT) architecture to be scaled up to 1 billion parameters. This massive scale is a key reason for its superior ability to understand and follow complex instructions. Why is this a game changer? For decades, creating 3D character animations has been incredibly costly and time-consuming, often requiring expensive motion capture studios or painstaking manual keyframing. HiStream 1.0 drastically lowers that barrier. Game developers can now rapidly prototype NPC movements or even create final character actions, and animators can generate complex sequences for films and virtual reality with unprecedented speed. Today, we're diving into a groundbreaking paper from Deepseek AI. At the start of 2026, they released MHC, a fix that solves this decade-old problem and could change how all large AI models are built. To understand this breakthrough, you first need to understand how AI models learn. Think of the information flowing through a model like traffic on a highway. For years, models used a design called residual connections, or ResNet. Deepseek's solution is incredibly elegant. It's called Manifold Constrained Hyperconnections, or MHC. They kept the multi-lane superhighway but introduced a strict set of mathematical rules of the road. Using a technique that constrains the connections to a mathematical structure called a Birkhoff polytope, MHC ensures that the total amount of signal in the system remains constant. So, what does this elegant fix actually achieve? The results from Deepseek's tests on models up to 27 billion parameters are impressive. This is essentially free intelligence. You get a smarter, more reliable model without having to just throw more money and computing power at the problem. This isn't just a minor tweak, it's a fundamental shift. For the first time in 10 years, a core piece of AI architecture has been successfully redesigned. Deepseek's MHC provides a stable and efficient path to scale AI models even further, potentially into the trillion-parameter era. By open sourcing this research, Deepseek is giving the entire industry the tools to build better, more reliable AI. It proves that the future of AI isn't just about who has the most GPUs, but who has the most GPUs, but who has the most innovative ideas. Researchers from Tsinghua University and Kuaishou Technology have just unveiled HiStream, a new model that can generate high-fidelity 10224-pixel video in real time. This isn't just a step forward, it's a giant leap that could redefine everything from video conferencing to live streaming and gaming. Previous top models, like Sora, are based on a diffusion architecture. They are fantastic at creating stunning, high-resolution videos, but they are incredibly slow and computationally expensive. They work by starting with digital noise and gradually refining it over dozens of steps, which takes a lot of time. Faster models exist, but they sacrifice quality, often producing blurry, low-resolution, or short video clips that lack consistency. No one had managed to crack the code for generating high-quality video at the speeds needed for live interaction, until now. HiStream introduces a completely new approach. Instead of the slow, iterative diffusion process, it uses a clever two-stage pipeline designed for pure speed and efficiency. This architecture allows HiStream to be incredibly fast while maintaining the visual quality we expect from top-tier models. So, maintaining the number Suez globals. That's stock numbers, because they are staggering. On a standard NVIDIA L40S GPU, HiStream can generate a 2-second, 1224x576 resolution video at a blistering 77 frames per second. To put that in perspective, that is fast enough for smooth, real-time video generation. It blows past the speed of previous models while achieving state-of-the-art results in image quality and how well it follows the user's text prompt. It's the first model to truly deliver on the promise of live, AI-generated video. A team of researchers from UC San Diego, alongside Google, has just introduced IQuest Coder, a new model that transforms AI code generation from a one-way street into an interactive dialogue. Let's break down what this means. If you've used an AI coding assistant, you know the routine. You write a prompt, and the AI gives you a block of code. If it's not quite right, you have to rewrite your entire prompt and try again. It's a frustrating cycle of trial and error. These models are great at one-shot generation, but they fail at something that's core to human collaboration, asking for more information. They can't ask, which version of the library should I use? Or what should happen if the input is empty? This lack of interactive ability is a major bottleneck. IQuest Coder is designed to solve this exact problem. It's built on the principle that the best code comes from asking the right questions. The researchers developed a new fine-tuning dataset called IQuest, a collection of over 800 real-world programming problems that require asking clarifying questions to solve. The process is revolutionary. Instead of just spitting out code, IQuest Coder can analyze a user's request and, when it detects ambiguity, it generates a relevant question to ask the user. This interactive loop of question, answer, refine allows the model to progressively build a better understanding of the user's intent, leading to far superior code. The results are compelling. When tested on a challenging benchmark of competitive programming problems, IQuest Coder significantly outperformed even the most advanced models like OpenAI's GPT-4. Crucially, after just a single round of asking a question and receiving feedback, the model's performance on a difficult dataset called Live Code Bench jumped from 17% to over 26%. This proves that the ability to ask questions is a powerful tool for improving accuracy. It's not just about having more data, it's about having the right data, and IQuest Coder knows how to ask for it.